Now, let's discuss how to apply the weighted average cost of capital in the capital budgeting. In the capital budgeting, we have to make the decision whether accept a project or reject a project. Sometimes, we have to make the decision, whether close a division of a firm or not. Then in this case, we have to use, we have to use discount rate. How can we determine the discount rate? After we know the weighted average cost of capital, we know this could be used as a discount rate. However, this application is under the assumption that the risk of projects or divisions are the same as the risk of total assets of the firm, or under the assumption the risk of proposed projects have the same risk as the risk of total optional assets of the firm. Okay. So generally speaking, in the capital budgeting, we can use the WACC as our discount rate of capital. However, using WACC as our discount rate is only appropriate for projects that are of the same risk as the firm's current operations. Okay, so that is very important, right? If we are looking at a project that is not of the same risk as the firm, then we need to determine the appropriate discount rate for that project. Okay, sometimes the first the project's risk is higher or lower than the overall risk level of the optional assets of the firm. In this case, we have to be careful. If we just apply the WACC as a discount rate to make the decision about whether accept a project or not, then we would make a mistake. Divisions, also often requires a separate discount rates. A firm would have different divisions producing different products or service, or a company has different lines. Then in this case, the different divisions have the different risk. Then in this case, when we evaluate the value of these divisions, then we have to use different discount rate. Now let's look at an example to explain. What would happen if we use the WACC for all projects regardless of risk? Okay. Now, assume a firm has a WACC 15%, and the beta of total assets. Please careful. Okay, here I said the beta of total assets. The total assets is an asset, right? Then for this specific asset, it has its own beta. Now let's suppose the beta of the total assets are 1, And on the market risk-free rate is 3%, and the market risk premium is 12%. Now the firm has 3 proposed projects A, B, C. We have estimated these 3 projects IRR. Okay, this column shows that their IRR. So, for project A, IRR is 17%. For project B is 18%, and project C is 12%. Okay, now first of all, let's assume these 3 projects have the same risk, have the same level of risk as the risk of total assets. Okay, then in this case, we can use WACC as a discount rate, right? Or as the required rate of return, because each project A, B, C have the same risk as the total assets that is operating right now. Okay, and then we can use WACC, weighted average cost of capital, as a discount rate to make the decision about whether accept these projects or not. Okay, in this case, what we should do? Of course, we are going to in this case, the 15% is the required rate of return, okay, or is the discount rate, right? Is the required rate of return. Then we compare, according to our decision-making rule of IRR, we compare IRR with 15%, right? If IRR is greater than 15%, we accept the project. Otherwise, we reject the project. Now let's do it one by one. For project A, IRR is 17%. Is greater than 15%. Then in this case, we accept this project, right? And now let's look at project B. Project B is IRR is 18%. Is greater than WACC. Of course, we accept it. Now let's look at project C. Project C has the IRR 12%. It is smaller than 15%. It is smaller than required rate of return. Then in this case, we will reject project C. Right? Okay, this is how we make the decision. Assuming the projects have the same risk level as the risk level of total assets that is operating. However, just as I said, each project may have their own risk. Okay, then we can estimate. In order to estimate their own systematic risk, because we know systematic risk matters, right? So we can estimate each project's systematic risk. And suppose we have estimated the systematic risk of each project, and their beta are shown. Their betas are shown in this column. Okay, project A has a beta. Project A has a beta 1.417. Project B has a beta 1. And what does this mean? That means the project B has the same risk as total assets, or project B has the same risk as the market portfolio, right? And project C has a beta 0.583. Okay, after we get the beta systematic risk, we can use campaign to estimate their individual required rate of return. Higher risk will require a higher rate of return, right? For project A, of course, what is the required rate of return? I think it is easy for us to calculate, right? I use RA to represent the required rate of return on project A. Then that is risk-free rate. What is the risk-free rate? Is 3%. Okay, 3%. Plus beta of project A, 1.417. Then times market risk premium, 12%. Okay, then we can get the number that is 20%. So I put the number here. Okay, according to the systematic risk of project A, its required return is 20%. Okay, I'm going to calculate their required rate of return using campaign for all these three projects, and then I'm going to make the decision project by project. Of course, for project B, what is the required rate of return? Its beta is 1. Okay, very simple, right? Because it's beta, its beta is the same as the market portfolio or as the total assets of the company. Then its required rate of return should be the same as WACC, that is 15%. Okay, and now let's look at the project C. Now we're going to calculate the required rate of return for project C. Okay, risk-free rate plus risk plus beta of project C, that is 0.583 times the market risk premium, 12%. Then we can get that number. That should be 10%. Okay, I put the number here. Now, of course, yeah, we should make the decision according to their specific risk, according to their specific required rate of return. Okay, now, yeah, we're going to make the decision for project A. For project A, is IRR is 17%. Is 17%, and its required rate of return is 20%. In this case, IRR is smaller than required rate of return. Then what are we going to do? We reject the project, right? For project B, is IRR is greater than required rate of return. Then we are going to accept it. For project C, now we can see the IRR is 12%. Required rate of return is 10%. Then we're going to accept it. Okay, now you can see. Okay, if we use different assumptions, then we can have different results. And now, yeah, if we assume the project A has the same risk as the total assets of the firm, then we would make a mistake, right? We accept a project that we should reject it based on or according to its specific risk. Okay, and also, yeah, we may made a mistake for project C. Okay, if we use WACC, we're going to reject it. However, if we have a closer look at its risk, we can find this project has a very small risk. Then required rate of return is only 10. Is only 10. Okay, then in this case, we should accept this project. If we use WACC, that means yeah, we would make a mistake, right? We would reject a project that we should have accepted. Okay, so yeah, from this example, yeah, we realize it is important, yeah, to use, it is important to estimate the project's individual risk and estimate their individual required rate of return, and then make the decision. Okay. Now let's see. Yeah, how can we estimate the project's individual risk and individual rate of return? Yeah, individual required rate of return. We can use a pure play approach. What is a pure play approach? Now let's look at. We can for a project. We can find one or more companies that specialize in the product or service that we are considering. Yeah, for example, if our company, yeah, will have a project to produce beer, okay, to produce beer, then on the market we can find one or more companies they specialize in the production of beer, okay, or their main projects are beer, okay, and then we can compute the beta for each company, okay, and then take an average, and then use that beta alone, yeah, and then use this average along with the campaign to find the appropriate return for the project over that risk. Okay, after we get the average beta of a couple of companies specializing in the same projects, then we can use this beta. We can apply this beta into the campaign and find out the required rate of return for our project. Right? So that is one way. We call this pure play approach. However, in the real world, yeah, it is often difficult to find pure play companies, especially in real days. Many companies produce multiple lines of project, so it is not easy to find this kind of company. Now, in this case, we can use the subjective approach. Okay. We can consider the project's risk relative to the firm's overall risk. Okay. That means the firm's estimated WACC. Okay. And then if the project is riskier than the firm, then we can use a discount rate greater than WACC. Right? Yeah. We compare the risk of a project with the overall risk of the company. If this project is riskier than the firm, then we use a discount rate greater than the WACC. Of course, if the project is less risky than the firm, then we use a discount rate less than the WACC. Okay. In this case, we may still accept projects that we shouldn't accept it, or reject projects we should accept. Okay. But your error rate should be lower than not considering different risk at all. So yeah, in this case, because we have considered the difference in the risk between the project and the overall company, yeah, we can make a better decision. Okay. Now let's look at an example. If we use a subjective approach, now this column shows the risk level of the project. Okay, if a project has a lower risk, For example, the project is the replacement of existing equipment, then the risk is pretty smaller, is pretty lower, right? Then in this case, we can use the discount rate WACC minus 3%. We can estimate the WACC and then subtract 3% from the WACC. Then we can use this number as a discount rate of this project. If we have a project that has the same risk as the form, for example, the cost-saving projects, expansion of existing lines, then we assume, the projects have the same level of risk as the company. Then we can use WACC as discount rate. Of course, for some projects, it has, for some projects that have the higher risk. For example, you're going to produce a new products that the company has not ever produced before. Then in this case, the risk is pretty higher. Then in this case, we can use a discount rate that is WACC plus 5%. And for very high risk project, for example, you're going to develop a new line of business. Okay, you're going to go into a new sector. Okay, then the risk is pretty high. Then in this case, your discount rate could be WACC plus 10. However, if you have a project that is mandatory, for example, the pollution control equipment, okay, you have to take this project to comply with the regulation of government. Then you don't have to consider the discount rate, right? No matter what discount rate is, you have to take on this project because it is required by the government. Okay, so that is a slide to explain the different situations. Okay, now we have a comprehensive problem. Okay, I'm not going to do this in this recording. I think on the note panel you can find the right answer. So you can do this example yourself and make sure your answer is the correct. Is correct. Okay, so that is chapter 12, and also we discussed a part of chapter 13, the capital structure. Okay, and for this part, we will not have. Okay, so now you can watch this recording first of all, you can read the chapter and then watch the recording to have a better understanding, and then you can do the homework and take the exam. Okay, that is all. Thank you.